In this video, I'm going to talk about oscillators, what they are, how they work, and most importantly, how to build your own. So we're going to cover a whole bunch of stuff from making a regular oscillator like this. You can see in the scope here, it's a square wave. And then we're going to look at a bunch of ways to control the oscillators, so with touch, or this is using graphite. You can draw on a piece of paper, and then the resistance of the graphite will allow you to change the pitch of the oscillator. We're also going to do light control, and then you can do things like use your phone or anything that makes light, and you can change the pitch. And then we're going to go further. I'm going to talk about creating stepped tone generators. So that's where you can hear it's jumping up one note at a time. You're actually getting a harmonic scale, and then you can use that with your other types of control, so you can get sort of melodic scales. I find this is really useful to turn sort of noisy sounds into more melodic sounds. And then we're going to go a bit further and talk about different kinds of modulation. And in the following videos, I'm going to talk a whole lot more about this. But in this video, the first thing we're going to be talking about is really just how to make our core sound generator before we start looking at how to make patterns and how to make music and how to make more complex sounds. We just need to make our sound generator, our core block. And then we'll be able to get into this other stuff. So the first thing I'm going to do is I'm going to show you the materials we're going to use, the electrical components, the tools, and this thing right here. This is the OMSynth mini lab. This is a project I've been working on for a little while, and it's basically just a prototyping interface. Well, it's prototyping and performance. So this is where I build circuits, and then this is where I'm actually able to play them as well. So there's a variety of switches, potentiometers, these are more switches, touchpads, all different things that you can put into the breadboard so that you can build the circuit and then actually play it. And what this has is at the top, we have our power supply, we have a speaker and an amplifier, a mixer, a bunch of input and output jacks for connecting to other equipment, and then a bunch of controls here, some buttons and potentiometers, and some lights, so that we can quickly build circuits and test them out. So let's get started. I'm going to show you first the tools we're going to use, then the materials, and then we'll start building some circuits. So you're going to need some wire strippers and some tweezers. You'll need a breadboard, and in this case I'm using an oscilloscope, but you really don't need that. As far as the materials we're going to use, you're going to need some wire. I like to order a bunch of different colors. And then these are these nice jumper wires. I ordered a bunch of these on eBay. And for electrical components, we're going to use some resistors, some capacitors, and some integrated circuits. And I've tried to keep this as simple as possible, so I'm just using sort of the most common values. So for the resistors, I'm using 1K, 10K, 47K, 100K, and 1M. And for the capacitors, I'm using 0.01 microfarad, 0.1, 1, 10, and 100. And for this video, the IC we're going to use is the CD4106. This is sort of one of the most common experimenters on integrated circuits. So first, we're going to talk just a little bit about what this chip is. So this is a 14-pin chip, and it's a hex Schmitt trigger. I'm not really going to explain what a lot of this stuff is. If you're curious, there's lots and lots of resources that are better than I can explain it. But I'll just show you really quickly. So this is basically a hex inverter. It's a logic chip. and it's got 6 of these little independent inverters in it. And you power it here. That's where you apply power. This can take anywhere between 3 and 18 volts. We're going to be running it on 9. And then we're going to use these individual inverters to make oscillators. And what's really cool about this chip is that every single one of these can be an oscillator. So we can make 6 oscillators with this chip. The pins are numbered like this. 10, 11. Okay, so I'm going to start by making an oscillator, and then I'll show you the schematic and explain a little bit about how it works. So first we're going to put the chip in the board. We're going to run power to pin 14, so that's going to be a little jumper here to the positive bus, that's the red line here, and another wire to the negative bus, or the ground there. Then we just need 2 more components. So we're going to take a 1 microfarad capacitor and plug that into pin 1 to ground. And then we're going to use a 1000 ohm resistor between pins 1 and 2. And then I'm going to plug that into my mixer, which the OMSynth is right here. So here's the square wave, which you can see here. We can also get a triangle wave, which we can look at there. It's much quieter, but it's a triangle wave. And if we want to make another one, we just need 2 more components, another capacitor and another resistor. And if we listen to that, we've got another oscillator. This one is obviously a much lower pitch. Okay, but there's very few situations where we're going to want just a static tone like that. So the first thing we're going to do is make this so it's a variable pitch. And we're going to do that using a potentiometer. So this is a variable resistor. So I'm going to plug that in here between pins 1 and 2. And then I'm going to plug in to my amp. And let's look at it on the scope again. And now we've got our variable pitch. Okay, so now I'm going to explain to you how this works, and then we're going to build a whole bunch more oscillators. So we've got our chip here, we've got our little inverters. They're actually Schmitt triggers, which you have to draw this little thing there. But so let's zoom in a little bit, and I'll show you the schematic and tell you a little bit. I'm not going to get deep into the physics of this. Doesn't really fit in the scope of this video, and there's a lot of other people that can explain it a lot better than I can, but just to give you an idea of how this works, and at least to show you what are the things that we want to look at as we're experimenting. So as I said before, we've got 3 components that make this oscillator. One is this Schmitt trigger, this logic inverter. One is a capacitor here, connected to ground, and there's a resistor that goes from the input of the inverter to the output. And in this case, we'll say it's pins 1 and 2 of this chip here. So what determines the pitch is the relationship of the resistor to the capacitor, and we can change either of these to change the pitch. So for an audio oscillator, I'm probably going to use like a 1 microfarad. But for a sub-audio oscillator, I'm going to use a 10 microfarad, so that's a 10 times bigger capacitor. And for a really slow oscillator, I'm going to use 100 microfarad. So by increasing the size of the capacitor, I'm lowering the pitch. And the same thing goes for the resistor. When I increase the size of this resistor, then it will lower the pitch. So I just drew the arrow there, which means this is a potentiometer. It's a variable resistor. So that means I can change the resistance, which changes the pitch. Now what happens, to put it super briefly, is that this is a device that looks at the input and that affects the output. So when the input is high, so let's say it's at 9 volts, then the output is going to be low. And what happens is this capacitor fills with charge. And when it's full, that's 9 volts. And then this is 0. So the charge starts to leave, and it actually goes through this resistor. And it empties until it becomes completely empty, and now that represents 0 volts. This is not 100% accurate, but for the sake of keeping it simple, I'm going to keep it simple. So once this is empty, now this inverter looks at the input and says, hey, this is 0. I'm going to be 9 at the output now. I'm going to go up to 9 volts. And what's going to happen then is that charge is going to go back the other direction, and it's going to fill up this capacitor. And now this capacitor is going to be full of charge, and that's going to be like 9 volts. And the inverter will look at that and say, hey, that's a high voltage. I'm going to go low now. So then the charge is going to leave, and it's going to go the other side, and this will empty. And it just keeps going back and forth and repeats forever. And that's your oscillation. The rate that it does that is what makes your pitch. We take this output, we send it to an amplifier, that goes to a speaker, and then we hear sound. So the takeaway from this, though, is that we're going to be playing with the value of the resistor and the value of the capacitor to determine how long it takes for this capacitor to fill. So a bigger capacitor takes longer to fill, and when it's full, that represents a high voltage, and this is low, and again, it goes back and forth. So a smaller capacitor fills more quickly. A smaller resistor will let more current through to fill up the capacitor more quickly. So what we're going to do next is we're going to play with different types of resistors. This is easy to do. Capacitors are a lot more difficult to play with. That's harder to change. So if I take this multimeter and I hold it in my hand there, you can see that that is 0.699 million ohms. So it's, well, now it says 800,000 ohms. If my hands are wet, it's less resistance. If they're dry, it's more resistance. But we can also get resistance with graphite on a piece of paper. That's another thing. So if we put our meter here, we can see now we've got, it's moving around a lot. Looks like 40,000. If I move it farther away, we're going to have more resistance. So now it's 250,000. And the other thing we're going to play with is a light sensor. So we've got this light sensor here, and got my meter, and we hold it up here, and you can see that there's 1,500. Oops. Hard to hold. Okay, so it changes with the light. So now it's 5,000, there's more light on it, and it'll be 1,500 ohms. So these are all things that we can change the resistance, which will change the pitch. So what we're going to do now is we're going to play with those different possibilities. Let's make an oscillator, and we're going to listen to it here. So again, we've got our pitch there. But now, instead of a potentiometer, let's use a light-sensitive resistor. Plug that in. And you can hear I'm changing the pitch depending on the light that falls on it. Now this is a really common light-dependent, it's an LDR, light-dependent resistor. And at full light, it's about, I think it's like 2K, and in complete darkness, it's about 1 million ohms. So that's a really good range. We can get a really broad sweep with this device. So then let's try another example. So we're going to take, so this is the input and the output of our inverter. But again, I should say this Schmitt trigger, it's a special kind of inverter that I encourage you to look up and read all about. And we're going to take some alligator clips here. We're going to connect those to the input and output. And now let's see, if I touch them, you can see the pitch is going up and down. Okay, but you can see that range is not so great. It's a little too low. So how do we change the range? Well, as I was saying before, we can change the capacitor. So I'm going to take out this 1 microfarad capacitor, and now I'm going to put in a 0.1 microfarad. So let's plug that in. So that's between the input and ground. I'm putting this capacitor. This is a 0.1 now. And I'm going to turn the volume up. And when I touch this, you can hear the pitch going up and down. So we can try, let's clip that again to our paper, and let's hear the pitch going up and down. Well, let's try another drawing. So you can do a lot of different types of things. Maybe you want to make some sort of pattern. And the more graphite there is, the less resistance there will be. So, which I'll show you. So, and that goes down pretty fast. But maybe I want, so at this point, but as I put more graphite, you're going to hear the pitch will go up. So you can really tune it to be at different nodes. If you want it to be different notes, you can just sort of add more graphite until it gets to the note that you want. So that jump is too big, so I'm going to add a little more. There, those are the two notes that I want. And maybe there's a third, but that'll be quite a drop. Okay. So there's some of the basics of using different kinds of resistors. And we can make all kinds of noise synths, light oscillators, touch, like a light theremin to change the pitch, touch controls to change pitch. But now let's go further. So what I find is that a lot of the time these oscillators, I want to do something a bit more musical. So I don't want to just make a bunch of random squealing tones. So the next thing I want to show you is how to make a stepped oscillator. And what that is where I'm going to use one oscillator. So I'm going to build another one. It's going to be the same way, where I've got my inverter. This time I'm using the second one, and between the input and output I'm going to have a resistor. And at the base, I'm going to have a capacitor. But what I'm going to do is I'm going to take the output of that oscillator and I'm going to feed that into the input of another one. Like this. And these are both variable. Okay, and let's plug these to potentiometers. And what's happening is I'm feeding one of these oscillators into the other one through a capacitor. So as the current is going back and forth and it's doing that bounce back and forth that makes our oscillator, we're also getting a little bit of signal from this one. It is syncing this oscillator to that one. And rather than trying to explain it, I'll just play it for you and you'll see what I mean. So you can hear as I'm changing the pitch of this oscillator, it's jumping notes rather than doing a steady glide. So here's the master oscillator and you can hear that one is smooth, but the one that's being controlled is not. And you can do a lot of cool stuff with this. So I can change, if I go to a lower pitch, now I get this tonal change. And then if I go to a higher pitch, I'm going to get steps. So now, if I plug in my keyboard again, and we can use a whole bunch of other things. We could use touch. We could use a light sensor. So let's just clip the light sensor to the banana, or to the alligator clips. So here you can see there's a light sensor. And then let's lower our master oscillator. So you can hear you're getting a nice sort of, almost like a filtering effect. Okay, so now we've covered a bunch of different ways of changing the pitch. And we've built a couple oscillators. Now, next what I want to do is we're going to build another oscillator, and we're going to start playing with creating relationships between oscillators. So we've already done that with the sync, so that's where one of them is syncing the other, but now we're going to make an LFO, and that's going to modulate the pitch of one with a much lower oscillator. So what I'm going to do is I'm going to take a large capacitor, so I'm using a 10 microfarad, oops, and I'm going to build that, I'm going to make that oscillator right here at the top. So again, in our chip, we've got inverters all along the top and bottom. So I've used this one and this one, now I'm going to use this one here. I like to use the ones in the four corners because they're easier to get at. The ones in the middle are a bit trickier. So I'm going to take two more of my jumper wires, and I've put my capacitor in place. Now I'm going to put in a potentiometer so I can change the pitch of this. And now I'm also going to introduce LEDs. So what I'm going to do is I'm going to take the output of this, and I'm going to take an LED. I'm going to connect that here, and then through a 1K resistor, I'm going to be able to look at the signal. So there it is blinking, you can see. And the schematic for that. Here's my oscillator. There's my capacitor to ground. Then I'm going through a 1K resistor. So this is 1K. This potentiometer is 100K. I didn't say that before. Right now we're using a 10 microfarad. This is my Schmitt trigger inverter. And then we've got our LED. Well, let's do it like this. We've got our LED going to ground. Okay. So, and then you can see as I change the, well, and we won't call it pitch anymore. Now we'll say as we change the frequency of the oscillator, you can see the light blinking. So what I'm going to do is I'm going to take my oscillator here, that's light controlled, and I'm going to hold it up to the light. Now that pitch is a bit too high, so what I'm going to do is I'm going to remove that 0.1 microfarad cap, and I'm going to put it in a 1 microfarad. So that's a 10, that's a 10. There we go. So you can see the pitch is going up and down with the light of that. So if I was to draw that as a schematic, I would have my LDR here. So that's, and then I've got my inverter, my cap to ground. There's my LDR, which goes between the input and the output. And then that goes out to an amp, to a speaker. So this one is making light, which is going to that sensor, which is changing the pitch of this oscillator. Okay, so now for the last part of this video, we've got our oscillator, we've played with syncing the oscillators, we made a low frequency oscillator with a light. Now I'm going to show a way of connecting oscillators directly together. So maybe we want to make an LFO not using light. We just want to plug one oscillator into the other. So what we're going to do is we're going to make, this is our low frequency oscillator. So we're going to use a 10 microfarad cap. Then in the feedback loop, we've got our 100K potentiometer. And now we've got, this is the oscillator we're listening to. So this has a 1 microfarad cap. So remember before I was saying 1 microfarad is generally in these applications for an audio oscillator. This is for a sub-audio. Then we've got, again, our 100K. And this is going to go out to an amp and to a speaker. We're going to listen to it. And what we're going to do is we're going to run that through, you can run it through a resistor, a 10K, but we want to make it a variable. And this will modulate the pitch of that. Well, let's do that first. So So I'm going to take the output of that one, I'm going to run it through a 10K resistor. So again, this is our audio oscillator, and we're going to add a 10K resistor to the input. This is the capacitor to ground. And then I'm taking the output of our other oscillator, so let's listen to it, and I'm going to plug that in here. And then you can hear the pitch going up and down. So that's an effective LFO. And now what I can do is I'm going to take that, and so that I can make it a variable LFO, I'm going to plug it through a potentiometer. So instead of just going straight in, my wire is a little too short. Let's get another wire. So now I'm going through this potentiometer and then to the input. And so there it's relatively soft. And now it's much deeper. What I did is I left the limiting resistor in place so it can't go too low, but if I remove that, then I can just go straight in and I can make it go so deep that it actually kills the oscillation. So if you like squealy, dying electronic sounds, then maybe this is for you. And then finally what I'll do is I'll put this capacitor from the output of my high frequency oscillator. This is where things probably get a bit confusing. I'll include schematics of all this. If you look in the description, there are links to schematics where you can see what I'm doing. But in any case, I'm taking the output of my high frequency oscillator through a capacitor to the input. So now we've got a stepped tone that's jumping up and down in harmonics. So that's the basics of making oscillators. There's tons of different designs. There's so much better designs. I didn't address, these are current controlled oscillators. There's voltage controlled oscillators, which is sort of the backbone of analog synthesis. But they use, dozens of components or hundreds of components. This uses 3. So I think this is as simple as it gets. And this is really, just meant to get you started and to really get you exploring. And even with the most basic oscillators, there's so much you can try. So I encourage you to experiment with light and with making these graphite synths, with linking them all together. And in the following videos after this, I'm going to be showing a whole lot more about how we do sort of complex modulation, making sequencers, which I'll be showing you how to make next time, which is not powered right now, but this is an 8-step sequencer that does all kinds of magic, crazy stuff. But there's a whole world of wonderful, wacky stuff you can do. And I'll demo a few of those now, but won't really be explaining them. But yeah, leave comments below. If you have questions, let me know. Share your discoveries. I don't know what the fuck else to say. you.